Yeah, uh, good everyone. So today will be our last class. So let me share my screen. So I'll be treating ordinal logistic regression. I've explained binary logistic, multinomial logistic. So today I'll be talking about ordinal logistic regression. We know when we use binary logistic, we use logistic regression when the dependent variable is a categorical variable. We use binary logistic when it has two levels. We use multinomial if it has more than two levels and you can't order them. We use ordinal when you have more than two levels and you can order them. For example, grades of students A, B, C, D, E. We know A is greater than B, B is greater than C, C is greater than D, D is greater than E, and E is greater than F. So because I can order them, that means I can use ordinal logistic regression. So today's class will be very brief. So how do we do ordinal logistic regression? So I have a data set here. So remember, regression is to study the relationship between variables. We want to know how different factors affect or influence your dependent variable. So in this case, our dependent variable is the number of the family size. So that's our dependent variable. And we can order them. 2 to 5 is greater than 6 to 9. And 6 to 9 is greater than, 2 to 5 is less than 6 to 9. And 6 to 9 is less than 10 and above. So we can order them. So this is our dependent variable. And it's a categorical variable. So that's why we are using for the logistic regression. And we have more than two levels. That's why we are using either multinomial or ordinal. Then you can order them. That's why we are using ordinal logistic regression. So now the first thing you have to do when you want to do ordinal logistic regression is to go to utilities, go to OMS control panel, you click tables, you look for plum, then you choose parameter estimate. Then you come to file and write any name. I like writing plum. Then you click add. Then you click OK. Simple. OK again. So that's all. Then you run your ordinal logistic regression. Then analyze regression. I will just use few variables to show you because I think using few variables to show you, if you understand it, you can do for more than the variables I will show you. Okay, let me set something first. This should be in scale. You double click this, you go back to your data view. This also should be in scale. Correct. I just want to ensure that I describe my variables correctly. Correct. So I can go to analyze frequency. Let me see something. Let me just do a frequency, which is not part of what I'm teaching. I just want to check something. I want to check the variables I will include in the model. So I will include age. I will include age, then maybe source of income, then category of staff. So let's do. So if you want to do the ordinal logistic, you go to analyze regression, ordinal logistic regression. The dependent variable, which I said we are using family size. So let's look for family size. So family size, the name is number of families. So that's it. That is what we use to label it, number of family size. Then the variable name is, look at it, you will see both the label and the variable name. So the label is number of family size, including parents and children, while the variable name is family size. So for now, this what you put in this box, this dialog box is the categorical variable. Then for this, you put continuous. What I mean by continuous, numeric. Numeric, like, let me show you what I mean. So this is what I mean by numeric, something like this. So if you have something like this, you put it in covariate. And if you have something like a categorical variable, you put it in factors. So we are going to use selected few variables, age, category of staff. Okay, let me just include one of these. So we can do with this. Then you go to output, you click test of parallel lines, then you click all this, continue. That's all. Or let's just click location. That's all. Now, in this case, you don't click OK. Don't click OK. Don't click OK. The reason is because if you click OK, it will not give you. Remember, when you want to interpret, you need exponent of this, but it doesn't give exponent of this. It doesn't give that. So don't click OK. Just click paste. So this is what will happen. Then all you have to do is you click enter. Look at where I click enter. This dot. This the full stop. So full stop means I'm done with writing. So you include what they call test, and you write the names of the variables. Now take note of what I want to do next. Remember the variables we added. Look at the variables here. We added 3 variables: age of staff and children alive. Age of staff and so added age, staff category, and children alive. Children alive is a numeric value, so it's not a problem. Yeah. So the 2 variables that we are going to consider are the categorical variables. Now, what am I doing here? You have to specify using test. If you discover that the levels, they are more than 2, you have to do what I want to do now. So look at this now. For age is more than 2, so I'm going to do something to it. The other variable I selected is what category are you in? It's not more than 2, so I'm not going to do anything to it. Now, assuming you have many variables, all the variables that have more than 2 levels, you are going to do what I want to do now. So what will you do? You look at the name of the variable. So after writing this test, you start writing the names of the variables. So after writing the name of the variable, it's supposed to be 1 equal to, then the name of the variable, like I explained, the ones with levels more than 2. So what we have here is age. Age is more than 2. So you write the name of the variable. Then it has how many levels? That's what you ask yourself. So let me check how many levels it has. Let me go to this place. Age has how many levels? It has 4 levels. 4 levels. So look at what I would do because it has 4 levels. I would write 1. Always start with the first variable, start with 1, 0, 0, and end with -1. Start with 1. So that's the 4 levels. I've represented the 4 levels. They're trying to communicate to SPSS to know how to manipulate the variable. So it has 4 levels. Now, assuming I have another variable that I want to include, what will I do? Okay, we are not done with this, so let's leave this first. But after writing the first variable, you use semicolon. No. Semicolon. You continue writing. Age, it must be case also. Then this for this next level, use, because the first one I started with 1. The next one will start with 0, 1, 0, and always end with -1. Always end with -1. It has 4 levels. So because it has 4 levels, I will do what I'm doing 3 times. If it has 6 levels, you will do it 5 times. So you start with, now it will be 0, 0. The next one will then be 1, and it will always end with -1. So that's the last thing. So I will put my full stop now. Assuming I have another variable I want to do the same thing. What will I do? I will remove my full stop, go to the next sheet and do this test equal to, then write the name of the next variable I want to work with. Then if it has, then count the number of levels it has. If it has 6 levels, assuming the next variable is sex, you do sex. If it has 6 levels, it means you will start with 1, then you will 0, 3, 4, 5, then the 6th one will be what? -1. You will continue repeating this. The next one will be sex 0, 0, 0, 1, 0, 0, 0, -1. The next line will be sex 0, 0, 1, 0, 0, -1. The next line will be sex 0, 0, 0, 0. So that's how you continue writing. So if it has 6 levels, you know that you will repeat this thing 5 times, and you'll be moving this one from the first place to the second place to the third place till you are done. Always end it with -1. And when you are done with the first line, you put a semicolon. Then the last place, you don't put a semicolon. Then when you are done for all the variables, you then use a full stop. Full stop now means I'm done writing this code. So full stop. So because I have only one variable, I will write a full stop. So that's all. So when you are done writing this, you click run and you click all. Run and you click all. So correct. So my result is here. So if you look at the result, you will see your estimate, which is your B, but you will not see exponent of B. We have B here, but we don't have exponent of B. So how will I get my exponent of B? That's the main thing. How will I get my exponent of B? Then you go back. Remember, I started with utilities. Go back to utilities, OMS control panel, and you end all. End all and click OK. Click OK. Wow. This is supposed to bring out a new sheet. It's supposed to bring out a new sheet. Give me a minute, please. Okay, so the reason why I had to pause it, I was trying to look for the reason why after clicking run, I didn't get the result I was expecting. So I discovered that we made a mistake. The mistake we made was in this tables. Then remember I said you click tables. I'm starting the analysis afresh, plum. Then I said you click parameter estimate. Now I wrote it here. It's not supposed to be here. It's supposed to be a new data set. Plum. So I will taking note of the correction. It's not supposed to be in 5, it's supposed to be a new data set. Then you click add. Okay. Okay. Then remember you go to what? Analyze, regression, ordinal regression. After selecting everything, you click what? Paste. So that's what you do. When you click paste, this syntax will open. Let me delete this. I've already explained it earlier. Then when it opens, you have to write your test and include the variables that have more than 2 levels. Then when you are done, you click run all. Then when you get your answer, you then click utilities, OMS panel control, and all the same thing I've taught, the same thing I've explained. Okay. Okay, then a new sheet is supposed to open. Look at it. A new sheet will open. Now, why are we doing this? Why are we doing this? The reason why we are doing this is because it gave me only value for estimates. It didn't give me value for the exponent of that this estimate is our beta. It didn't give me value for exponent of beta. Now we have 2 ways of doing this. You can decide to do all these things I've done. Then you take it. You can decide to do all these things I've done also, but if you don't want to do it, you can decide to copy your results from here, from SPSS, without doing all these things. Just click your normal OK, the way we did multinomial logistics. Then copy your results. Then take these values, estimate to Excel, and get the value for exponent of B. So get the value for exponent of B of this. So maybe you copy it. When you copy it, you create a new column. Then when you create a new column, then you calculate it manually for the exponent of B of this. So I don't want to calculate manually. That's why I'm doing all this. Now you can calculate manually if you want. So after doing this, what do? You go to File. So you go to File. You can decide to save this if you want. Okay, maybe let's try saving it before we continue anything. So I can save it in my desktop. So let me save it as Plum. You remember I said Plum is not compulsory. You can use any name you want. So I've saved it in Plum. Then you go to File, New, Syntax. What am I want to use SPSS to calculate the exponent of B of all the values. So what should I do? I'll tell SPSS compute exponent of B. Let me call it exponent of b. This is what I want to call. Remember, in name, you cannot give space. So that's why I'm using underscore. So what will be exponent of b? The function is ESP of estimate. Remember, estimate is in the table already. So that's why I'm using estimate. What else do I want to do? Compute. Okay. I have to tell SPSS I'm done with this. So telling SPSS I'm done with it, I have to put full stop. So that's what, so it's this is supposed to pop up. That I was not seeing it. That's why I knew I'm not getting it. Compute. So let me calculate the confidence interval, which if you need it, is not compulsory. I think the only thing you need here is exponent of b. But you can try to calculate the lower confidence interval of it and the upper confidence interval of it. So exponent of b. But where did I go to syntax to? Exponent of b of lower bound. We already have lower bound in our table. Look at the lower bound here. Look at it. So I want to take exponent of it. So I'm trying to use SPSS calculator to do this. I will do for upper bound also. So once you are done with that line, you click full stop. So full stop means I'm done. So compute again. So if it doesn't pop up, it means you are making a mistake. What's the name of it? I want to call it upper. And ensure this name, you can't use any name, but ensure that the name you are using is not already in SPSS, not being used already in SPSS. So I want to use exponent of b of upper bound. Then also it must be case sensitive. Must be case sensitive. Once you are done, you put full stop. So once you are done telling SPSS what and what you want to do, the next thing you do is you format it. What are you formatting? Then you write all the things you are doing. You calculated exponent of b. You must write the name of the things you want to calculate. You want to calculate lower bound, and you also want to calculate upper bound. F 8.3. So I'm trying to format it. Then the last step, full stop means I'm done. The last step is to execute it. Take note of all the steps. Full stop meaning I'm done. Then I'll click run all. So what I calculated should be here in the new table. So look at what I calculated, exponent of the lower bound, upper bound. Now, like I said, you can do this manually. You must not use the syntax that I use. You can calculate it manually. Just take it to Excel and tell Excel exponent of b, or you do it with your calculator. The same thing with the lower bound. Just take the exponent of the lower of this lower bound and upper bound. Just take exponent of b of it. So I just use the SPSS calculator using the syntax method to get this. That's it. So this is all you have to know about ordinal regression. So now let's talk about how to explain it. Explaining this, I will use a work I did. So I've shown you how to do this. Remember, in this work, I used only 2 variables so that it will be easy to explain. Now take note, when I was writing my syntax, I didn't write for staff category. Why? Because it has only 2 levels. But I wrote for age. I wrote syntax for age because it has more than 2 levels. Then I didn't write for child, this variable, children alive. Why? Because it's a continuous variable, quantitative variable. That's why I didn't write for it. So now let me show you a complete work I did and show you how I interpreted it. Now, every other interpretation will be here. Every other result will be here. So the reason why we have to do the plum using these utilities is so that we can be able to use the syntax to calculate the exponent of b, which is not compulsory. So you may decide not to even go to this plum at all. Just do this, then calculate the exponent of b of this and this. I think that's what I do most times. So I'm teaching you, that's what I'm teaching you now. So let me show you. So everything you need for this work is there. This is your parameter table. This is your test of parallel lines. You don't need this. You don't need this. So all the things you need for the work is there. So now let me show you how to interpret it. So the first, you have to test for the assumptions of ordinal logistic regression. So we are testing for the parallel, the proportional fault assumption. So what are we using to test for it is the parallel regression. These parallel lines, that's what we are using. So proportional odds assumption, also known as parallel regression assumption. So we are using the test of parallel lines for it. So look, this is the null hypothesis. The proportional odds assumption is satisfied, while the alternative hypothesis that is not satisfied, and we want it to be satisfied. If it is satisfied, the meaning is that the slope coefficient are the same across the response categories. That's what we want to achieve. This is the assumption for ordinal logistics. And based on the data, my result, the result shows that the data satisfy the assumption. So that means I can use ordinal logistic regression because it has satisfied the assumption. Now, this is a descriptive table, and I got it. Normally, what I do is I will just run a multinomial logistic with all the variables so that I can, because multinomial logistic will give me this table. Or you can do it yourself using, if you don't want to, I just do the multinomial logistic and just collect only this table from it. Or you go to analyze descriptive frequency and get it. So this is my frequency. You can decide to interpret it, maybe write. I've already taught you that you write something briefly on this. Or you can, most times I just leave it for my clients. If they want to write, they write. If they don't want to write, they can leave it. But you can, if it's your work or what you and your client discuss, you can decide to write brief description on this. So now I've taught you model of goodness of fit already. I've already explained it in both binary logistic and multinomial logistics. So we used to know whether after adding the all the variables to the model, whether it will perform better than the intercept only model. So in this case, we also, if we are using alpha at 0.10, we are rejecting, it means that it has satisfied the assumption. I've explained it already. Then this is another goodness of fit test. It's not compulsory to use it because this is a goodness of fit test. Sometimes I can use it, sometimes I ignore it. So it's also a goodness of fit test. So it's just to test if the model fits the data very well. And we want this thing to be greater than your level of significance. You must not use it. You can decide to use it or not to use it. Then the next thing is pseudo arrow square, which I've also explained. You must not use it. The three of them, they do goodness for goodness of fit test. Now, this is a pseudo arrow square. So sometimes you may decide to ignore it because of, remember I told you it's trying to mimic the arrow square from OLX. So based on this result, it's telling me that the model is not performing well, which doesn't tally with this and this one. I can try to ignore it because this value is pseudo arrow square. Maybe it doesn't perform really well sometimes. So there are sometimes it may not perform well, so you can ignore it. But take note of this. This is a good test, goodness of fit test. This is also a goodness of fit test. The three things are just to test if the model is a good fit. So you can try to use maybe some of them, or then this is the parameter estimate table. So this is what the first analysis without writing your syntax will only give you this, what I just highlighted. Then the essence of the syntax is to get this. The essence of the syntax is to get this. That's the essence of the syntax. So what I normally do is I can copy the result from, if I don't want to write the syntax, I copy the result from this without writing syntax. Then when after copying the result, I paste it to Word. I come to this place. I click up, right click. Then I go to insert. Then I can insert column to the right. That's what I will do. I will insert column to the right. Then I will calculate it manually. That's if I want, or I use my syntax to calculate it, depending on. Now, why is it good to use syntax? If you are working with many variables, it may be difficult to calculate it manually, time consuming. So why not just write your syntax so that SPSS can calculate everything for you? But if you decide to calculate it manually, your choice. So this is what I did. Then I was the one that edited the name. So you put the name you want. Remember what I wrote in SPSS is what I wrote. Exponent ESV, then underscore B. So when I wanted to copy it, I had to rename it exponent of B for the same thing. So remember what we explained, we check this, and we check the significance of the variable. The significance of the variable. Significance of the variable. So let's check this. This significance of the variable. So in this case, location, the staff category is significant. Gender is not significant. Gender is not significant. So what you just interpret is that gender does not affect the family size. Gender does not affect the family size. That's all. Education qualification is also not significant. So that means education qualification does not affect the family size. So what are we trying to do in this study? This study is trying to look if different factors can influence the number of children the family will give birth to. So is it that if they are non-teaching staff or teaching staff, will it have any influence on the number of children they will give birth to? Talking about male staff, female staff, will it have any significant effect on the number of children they will give birth to? We'll talk about the educational qualification. They have MSc, PSc, PhD. Will it affect the number of children they will give birth to? Will their monthly salary affect the number of children they will give birth to? Will, if they have another source of income apart from what they earn as a university worker, will it affect their family size? So now the essence of this work is to end up in decision making. You make recommendations and tell them things that can influence the family size of university workers. So gender does not affect, education qualification does not affect. If you look at this, depending on what you're using as your level of significance, let me see what we are using in this work. They're using 0.05. So using 0.05. So also monthly salary too does not influence. Monthly salary does not influence. And where is my P? Then, but if you have another source of income, it will influence. If you have another source of income apart from what you earn as an investor worker, it will influence. So the two major variables that influence family size, staff category, and income source. Now, how do you interpret this? I've already explained how to interpret anything logistic regression, but let me just give you the unique interpretation of logistic regression. So all these variables that are not significant, we just tell them they are not significant. So the gender, highest qualification, and monthly salary have no significance. Now you can try to write it this way or write it the way I've been doing it. Maybe you pick each of the variables and interpret. So I can just give a separate interpretation for gender and say gender is not significant. Then use my bullet point, give a separate another new interpretation for highest educational qualification, another interpretation for monthly, like I've been doing for binary and multinomial logistics. But for this work, I have to combine it. Like I told you, I've been saying you are free to do any method. You don't have to use a particular method for all your work. So in this case, I just gave a general interpretation for all the variables that are not significant. So gender, highest qualification, and monthly salary have no significant effect in the family size of staff of high institution in Imo State, and there is a body p-value. So now, then I also okay, this is the where I started talking about the variables that are significant. So the two variables that are significant are staff category. This staff category is significant. So that's why I'm interpreting it. So this is why I started interpreting. So look at it now. So the staff category has a significant effect. So I think it's even better to use bullet points, right? To be easy for everyone to use. So maybe I should have done something like this. I should have done something like this for the work. Then I do something like this. So remember, you just have to present your work well. Now, this is your choice, anyhow you want to live your work. So the staff category has a significant effect in the family size of high institution in Imo State. Since there is, so you state that it's significant or not, then before you interpret based on odds and based on what likelihood. So interpreting based on odds. So now your interpretation will be on the last level. The last level. What I mean is the odds of non-teaching staff having a large family size. So I'm assuming that the first family size is 1. The second family size is, let me check what we have in data for family size. We have up to 4 levels. So 4 levels. So let me do a frequency table and see if we have data for all the levels. Let me see. No, not this. Let's just go back. But your interpretation will be on the last family side. So the odds of non-teaching staff. Remember, we are comparing. Normally, I should have changed what is the meaning of 0, what is the meaning of 1. I should have changed it. So you go to it's your choice. So I didn't change it in this one, but you're supposed to change it. It's better you change it. You go to family size. That's family size. So family size. No. We're talking about staff category. Staff category. So 0 means non-academic staff. 1 means non-academic staff. So that means I should have changed this 0 to what it means and 1 to me what it means. So 0 means academic staff. So something like this. I can write academic staff. Then for 1, I can write non-academic. So that's what I mean. So that means I'm comparing non-academic. I'm comparing, academic to non-academic. Take note of this. By comparing academic to non-academic. So the odds of non-teaching staff having a family size. Let me see what is there. This is 1. 1 here means what? 1 means non-teaching staff. The interpretation is supposed to be this against this, academic against non-teaching staff. So that's what the interpretation will be. So the staff category there. So the odds of teaching staff having a large family size is 0.35 that of non-teaching staff. Now, how do you get this value? 0.351. You get it from the exponent of the. Take note. So we are comparing this against this. So the odds of academic staff having a higher. Now the interpretation for this would be that means because remember it's ordered, so it will be the highest level. So now the interpretation will be the odds of academic staff having a higher family size is 0.351 that of non-teaching staff. So having said that, you can interpret it based on likelihood. So this means that teaching staff, how did I get this 65? I've already thought how to get it. You just do 1 minus this and get the percentage. They are less likely. Why is it less likely? Because this is less than 1 to have a what? Large family size. Now, why am I using large family size? You always use because it is ordered, you use the largest value. So because the way it is ordered, family size 1, 2, 3, 4, the highest will be the last number. That's how I did it. Assuming when I was coding it, I coded it in a way that, okay, let me just use what is there. So the way I coded it, the least number was for the least family size, while the highest number was for the highest family size. So your interpretation would be related to the large family size, the highest number. So this means that teaching staff has 64.9 less likely. Why is it less likely? Because this number is less than 1, and also the estimate is negative. B is negative. Now, when I did my analysis, SPSS gave me the answer as estimate. I changed it to B myself. You also interpret this same thing. Now you have to know what 0 is, and you have to know what 1 is. So what are you doing? You are comparing 0 against 1. You are comparing 0 against 1. So this, I can try to put it in bullets. So having another source of income outside monthly salary significantly affect the family size of staff of higher institution in Imo State. Then you give your reason, then you interpret based on the odds ratio. The odds of staff that have other sources of income outside the monthly salary, having a large, remember we're talking about large family size. When I taught you binary logistic regression, I said your interpretation will be on the level that you coded as one, the level that you coded as one. For multinomial logistic regression, now the interpretation will be based on what you use as your reference level. Then for ordinal logistic regression, your interpretation will be based on what you use, what you coded with the highest number. So what I coded with the highest number is the largest family size. So the odds of having other source of income outside having a large family size is this times that of staff with no other source of income. Then let's say I have to interpret it based on what likelihood. Now, if you subtract one from this, now because this number is greater than one, you know that it's more likely. It won't be less likely. More likely. Take note. More likely. Then how will you get the percentage? Because of more likely, you do this minus one. For less likely, you do one minus the number. For more likely, you do this number here, minus one. So you get 1.06, then multiply by 100, which is 106.6% more likely to have a large family size when compared to staff with no source of income outside monthly salary. Now, another thing you have to add, you must state that all other variables must be held, given that all the other, so you have to state something like this, given that all the other variables are held constant. So you also have to state this same condition in this place. You have to state it here also, given that all the other variables are held. So you have to state it here. Let me do it one time. Given that, so that's all. Now, if you decide to talk about the accuracy, your choice. If you don't want to talk about accuracy, your choice also. So I just talked about the performance of the model. So just to accuracy. But if you want to do it your choice, do a bonus. Bonus now. So we are done with our class. We are done with this tutorial. Now, there are other things I've not taught. Let me teach you important things. Once you know the basics, you can know anything again. SPSS I have not done before. I accept it. Once I accept it, I try to learn it and I do the analysis. Now, if you want to learn any work in SPSS, what do? Just go to Google and type. For example, if someone says, they want to do a non-parametric test. They want to do Kruskal-Wallis. So I just go online and do Kruskal-Wallis test and put SPSS. Sometimes I put lead. Look at this. I think they have this LAEROD. They explain things a lot. So just search Kruskal-Wallis, maybe lead. If they don't have it, then you can use other tutors. Then since they have it, I click it. They will direct you on how to solve it. They will direct you. So they will explain it for you, state the assumptions. So this is a bonus. Then they will tell you how to do it. They will direct you how to do it. They will tell you, go to analyze, go to non-parametric, go to legacy, go to this. They will direct you on how to do it. They will even interpret it for you and show you how to interpret it. Are you seeing it? They will show you how to interpret it. Awesome, awesome. So always do this. Whenever you get any other work, so you can use this to practice. You get any other work that you don't know and you want to learn, just search it online. Maybe use LED. Why I like LED, they have a detailed explanation for it. Thank you for joining us. Thank you for registering for this course. I had an awesome time with all of you. God continue to bless you. And I will advise everyone to continue serving God. God is real. Jesus is real. So serve God genuinely. In all you are getting, get God. Just know that God is interested in our lives. The knowledge we are getting about SPSS is good. We also have to get knowledge of God. Serve God genuinely. and I wish you all the best. And lastly, I would advise everyone here to go and learn Arrow programming. After learning Arrow programming, then you learn Python. I would advise you don't move to Python yet. If you want to, if you ask me, I will tell you start with Arrow programming before you move to Python. But if you want to choose Python first before programming, awesome, your choice. Just my decision, just my advice. After this, don't relent, go and learn Arrow programming. I wish you all the best. Love you all.